Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hello, everybody. Thank you for joining us on a brand new episode of the Clear to Send podcast. Really looking forward to talking about this episode because it's an interesting topic. It's 802.11ax OFDMA Resource Units, and we're gonna dive into this in detail as Francois and I have been reading the 11ax draft. It's a pretty big document and complex.
You mean decoding?
Yeah. Trying to understand this, but yeah, Francois, you're here. Welcome back to another episode. How are you doing?
Thank you. I'm good. Thank you. How are you?
It's early this morning. I asked to delay this episode another day because I was still struggling to keep up with what's included in the draft and try to find all the sections related to resource units. There's quite a bit, right?
Yeah. It's for sure. It's an interesting read. It's not an easy read, but I think it's a good exercise. You just appreciate how much work the engineers from the IEEE put into this stuff.
Yeah, and then they've been working on this for a long time, right? For many years, and so as I'm finally getting into it, it's quite the document.
Yeah, I think it's about 650 pages, something like that. It's what I've found is that they don't have all the the definitions inside that document. So I was always going back and forth between the draft document and the standards, the 802.11 standards, to try to fill in the blanks.
Yeah,
because it's a lot of acronyms. And
there's too many.
Some old, some new, so you have to kind of decode and try to find out what they mean sometimes.
And it's difficult to go through it when it's a digital document and you're having to scroll and then you lose your place of where you are as you're trying to find definitions and find different sections. And I should have printed it out, but at a couple hundred pages, and then the standard itself over 1,000,
3,500, I think.
It gets costly to print those out.
Costs like a tree or something. Yeah. So, but I just used the Note app on the iPad, and I was just drafting the acronyms as I was going.
That's
so
a
I went
good
back
idea.
to paper, the digital paper. I mean.
Yeah, using this, I was using something similar. I use Bear to try to keep track of all my notes. But yeah, it's very interesting to go through, like you said, a good exercise. And I don't know if we'll cover every single thing about resource units, but we'll share as much as we know from going through the 11ax draft. But before we talk about resource units, we want to talk about some of the news that came out. The first one, we do want to thank someone who gave us a review on iTunes. This one's coming from Marcel T72. Gave us a 5-star rating. Thank you, Marcel. And he says, if you're a beginner or an expert, just listen to this podcast. You'll learn new things and hear different views on how to use and implement this great technology we call wireless. And I think that's a great review. That one came from international. I think that came from the Netherlands. So,
wow, nice.
Yeah.
Thank you, Marcel.
Yeah, thanks for giving that review. And if you guys want to leave us a review, let us know what you think and let others know what they'll be getting into listening to this podcast. Head over to cleartosend.net/iTunes.
All right. So second bit of news is the IEEE announced that they will be only supporting the new Wi-Fi 6 or AX standard on the 6 gig band when it's available to us to use. So I don't know what you think about that, Roel, but going through the documents and the draft, I think it's a really good idea.
Yes.
Because a lot of complexity from AX comes from the fact that they have to be backward compatible with what they call the pre-HE communications. So all the one we know. So I think it's a really good move, and it's going to bring more efficiency to Wi-Fi communications.
Yeah, because we were talking about this the other day, and I kept saying, Francois, this 11ax sounds so complex that I don't know how it's going to work with all the other devices, which we'll now call legacy once HE comes out, right? High efficiency, and having Wi-Fi 6 only work in this new band, the 6 gigahertz Wi-Fi band. I think that'll be a huge improvement because that's a huge band, and well, I think that is the best way to go.
And you can get like it's kind of like you get a fresh start. Right? They do that in cellular communications where they just rip and replace when there's a new technology and they get a fresh start. And they don't care as much about backward compatibility as the IEEE does with Wi-Fi. So you pretty much get the improvement from the new technology right away. Whereas with Wi-Fi, you always have this transition where most of the devices are not yet supporting the new technology, so you not get the full enhancements from the new technology. So, and especially with AX, where we don't necessarily get better data rates, we get better efficiency, but you only get better efficiency if everyone is AX compatible, right? Or most of the devices are AX compatible, which is not going to be the case for the next couple of years.
Yeah,
so I think it's a really good move.
Yeah, we don't want 11B devices to ruin everything in this new band because we're allowing this backwards compatibility. So I think this is the only way to do it moving forward if we're going to have 11ax be an amendment to the standard, and I think that will improve Wi-Fi considerably for everyone with this efficiency, high efficiency. The amendment that'll help us get to seeing all these benefits, and so looking forward to that, and hopefully that stays how it is.
So now the big question is, when is all of that going to be available to us? We're still waiting on AX devices. Clients, well, we're going to talk about the Samsung new phones. So they're going to come this year. But now are we going to have different waves of AX client devices? Like the first wave might not be 6 gig compatible, and then the second wave might be. It's not clear, right now? Yeah,
it's not clear. They are saying it's going to be 2 different waves, but who knows? I'm going to say it's going to be 2 different waves just so these device manufacturers can keep up and your AP vendors can keep up, right? I think it's a lot to add because you're going to have new APs anyways, especially with 6 gigahertz coming out, and they're saying maybe 2020 we'll see 6 gigahertz. I think that's very optimistic, but I don't know, we'll see.
Yeah. I think we'll have to wait. I'm super excited about this year, 2019, because we're going to start to actually see AX devices or Wi-Fi 6 devices, and we're going to be able to start playing with them, connecting them to access points, see how it goes. Reading the standards is a good exercise, but it's a lot of theory, and sometimes you just want to be able to look at a frame, right, a packet capture, and see, okay, what do I have in this case? What do I have in this field? And it's very frustrating, right? I don't know if you felt the same way, Roel, but sometimes it's very frustrating to only have the theory.
Yeah, it is, because it's theory, right? And there are things that are required, things that are mandatory, things that are optional, and you just don't know which ones will be added to these devices and APs. And it's great that we have APs that are pre-standard, they're draft 11ax draft, but we still don't have the clients, and that's where the Samsung Galaxy S10 is coming out this year. That's gonna be Wi-Fi 6, but once we actually see it in person and see what it actually supports, then that'll be the start. But I think because Samsung is so huge, they're big, a big player in the mobile space. I think this is really going to kick off the Wi-Fi 6 because now Samsung's now setting that standard, right? They're saying we are releasing a phone that supports Wi-Fi 6 later this year in 2019. So that's pretty exciting.
Yeah, and talking about Samsung, they announced 3 new phones last week. They announced the S10, the S10 Plus, I believe, and the S10e. And the S10e, it's kind of like the cheaper, quote unquote cheaper version of the phone. Is kind of like the response to the iPhone R. And what I really liked is that they put Wi-Fi 6 chipset in all of the new phones.
Yep.
Right? They didn't cheap out on the Wi-Fi for the cheaper version of the phone.
Yeah, like I mean, they support all of the wireless protocols. It's A, B, G, N, A, C, AX, and I wonder, like, as we keep continuing, are they all gonna support every single wireless protocol? Hopefully not, right? We'll end up having phones that ditch the legacy protocols. But yeah, it'll be interesting to see how this looks, and I'd like to get my hands on one once it comes out.
Yeah, I think by standard they have to be backward compatible. So maybe that's like a requirement for a Wi-Fi Alliance. I'm not sure about that, but
that's a different conversation.
Yes, yeah. So it's a great news, and like you said, the Samsung it's huge, so it's going to set the standard. I wouldn't be surprised if we start seeing Apple devices this year supporting Wi-Fi 6. Hopefully, the iPhone does. That would be a huge change.
I mean, we should see it, right? And if you ever look at the task group, the 11ax task group updates, I mean, Apple is in these discussions. They just haven't announced when they're going to come out with it, but I'm sure they're already developing it since they're very much part of this. They have a lot of discussions here with 11ax. So I can add a link to the task group updates, and you can see all the different manufacturers that are there, like Qualcomm's there, MediaTek, Apple, Broadcom. So everyone's taking part, and I think that's the thing. Like, all of this is driven by these device manufacturers. So
yeah, and I think they're gonna release other devices before the iPhone, maybe new laptops. So we'll see if they include Wi-Fi 6 chips in their new stuff before September, I guess.
Yeah, maybe we will see an update before the end of the year. I mean, Samsung's already got the edge over them, right? As Wi-Fi 6 is gaining traction, right? This new name that we're using, referring to 11ax, and maybe Apple's already thinking about releasing something soon to say, hey, yeah, we're right behind Samsung. We're going to try to get ahead of them.
I'm waiting for the Samsung Wi-Fi 6 fridge.
Oh man.
Anyway,
all right, so the last piece of news we have here, this one was found by Luke Jenkins. He shared this out in a Slack group. It's the from the FCC site is this new Cisco access point that was registered. I guess it's called the Cisco Catalyst 9115AX series access point.
My. Okay, so we have the Catalyst back in the AP space, huh?
Yeah, I guess it makes sense if Cisco's going to stick with the iOS XE based the new controllers, right? So now these new APs will be our Catalyst APs. So I think it'll be interesting to see when this actually gets released. I'm thinking maybe by Cisco Live we'll hear about it.
Yeah,
that would be a good time to announce this AP. We'll add a link to the FCC ID site, but what I did notice looking at the operating frequencies, I think they only listed Uni 3, which is interesting. Well, they did 2.4 and Uni 3 bands. I didn't see all of the Uni. So I don't know if it's interesting. Like, I don't know why they would just come out with an AP that's 2.4 and Uni 3 only. No reference either to maybe supporting 6 gigahertz. Maybe it's a typo. I don't know.
It's interesting. Maybe that's just a requirement from the FCC.
Yeah, I was just looking at it before we were going to record, and I looked at the frequencies, and I said, that looks very small. And then at the top, it does say Uni 3. But yeah, we'll probably see an update coming later on, and we'll try to see if there's any other APs that might be registered here on this site.
So I guess now we can know anything before it happens, right?
Yeah, I think that's how people figure it out. You could subscribe. I think you can subscribe to all of like a manufacturer's filings if you wanted to. When we add the link, you'll see like a breadcrumbs at the top, and Cisco Systems is there. When you click on Cisco Systems, the link, there's something that says subscribe to applications by Cisco Systems. So you could get notified whenever they register something with FCC.
Maybe after, someone will create the Wi-Fi leaks website. After WikiLeaks, you have Wi-Fi leaks.
Well, okay, so I went back and looked at the filings, and we're talking about the 9115AX. If you go back, they also registered the 9117AX the following day, and that was on February 13 and 14.
Are you investigating? Did you register the name?
Doing it now. All right. Well, it'll be interesting to see when Cisco finally releases their 11AX AP, and we know that Aerohive has already been selling theirs. Aruba is working on theirs. I don't think they're actively selling theirs yet, and Cisco has yet to announce theirs. So
I think Extreme announced theirs as well.
Did they? Okay. And I don't know if Ruckus did. I can't remember, but I mean, it's going to happen, right? We're just waiting for announcements.
All right. Why don't we talk about resource units?
Yeah, we delayed this enough. So, OFDMA resource units. In the previous episode, I kind of did an overview of 11AX, and I did touch upon resource units. It's brand new to wireless and how we think about how wireless is done, because when we talk about resource units, it's a way to, I guess the short way to describe this is being able to take a frequency or a channel and split that into smaller channels, and then those smaller channels, or what they call resource units in the amendment in this draft, 11AX draft. And so that's the interesting part, because when we talk about OFDMA, it's multiple access. And that means we can send multiple transmissions to devices, transmit and receive. Yeah. Whereas when we were talking about OFDM, that was just a single device. It would just take up the whole channel, no matter how big that frame was, right? The payload. So
yeah, I think that's the biggest change with AX is the fact that we're going to be able to communicate with multiple devices at the same time. Like you said, with OFDM, that's what we have right now with AC. It's a one-to-one communication, and everyone has to take turns. And then with AX and OFDMA, technologies like OFDMA and multi-user MIMO, now it's going to be a multi-user communication. So we're actually talking about this morning. In the draft, you see a lot of MU, which means multi-user. And for some reason, our brain has been trained to associate MU to multi-user MIMO from AC Wave 2. But if you go back to AX, MU refers to just the multi-user communications, right? And multi-user communications will be implemented by OFDMA and multi-user MIMO, right? So now you have two multi-user technologies that would play along together, and that makes it very confusing. That's
the first confusion there.
Yeah, that makes it very confusing. OFDMA, you take your channel, like Rowell said, you take for instance, your 20 megahertz wide channel, and then you subdivide that channel in smaller channels, in resource units, and then you assign those resource units to different users, so you're able to actually send data to multiple users at the same time. Multi-user MIMO is you take different streams and you assign different streams to different users, so you could actually do both at the same time.
Yes, and that's where it gets really complicated. And I think, I don't know if we're probably not going to dive that deep and talk about MU MIMO. We're going to primarily refer to the multi-user part of OFDMA in the sense of resource units. And you can do, like Francois said, the multi-user MIMO within the OFDMA resource units, but we won't go that far because it is a complex topic. It required a lot of reading. And when we talk about the resource units, every channel, or like your 20 megahertz, your 40, your 80, your 160, they have different resource unit allocations. Like there's different sizes, right? So this is where we, I guess, just jump into it. And we will include some images in the show notes. We'll also include a table that references the resource unit sizes per channel and what's available. And I think moving forward, I'm just going to call them RU because it's a
now you're talking acronyms, right?
Yeah, this is where the acronyms come in, and you might as well get used to it. So when we say RU, we're referring to resource units. And when we talk about resource units, it's just subdividing the channel into smaller channels. That's really what it is. And so what we're going to go into is how an AP will allocate a smaller channel, an RU, to a device on the downlink and also on an uplink. And so that's going to be pretty interesting.
It is. And then also what we can do is include the subsections that talks about that in the standard. We can include that in the show notes. So if you want to go back and read the draft, you can focus on these sections.
Mm-hmm. All right. So where do we begin on?
Maybe we can explain how the different size of RUs we can deal with, or the different size of RUs that are defined in the standard.
Mm-hmm. Yeah, and I think this is where an image really helps out. So I created an image because Francois likes creating images. I thought I'd try it myself. I created an image showing a 20 megahertz channel width and showing the different ways it can that channel width can be divided into RUs. And so you can have multiple types of allocations. And there's a 242 RU width, which occupies the whole 20 megahertz channel width. And then it further subdivides down. And it gets interesting because now you have one 242, they call it a tone.
Which is a subcarrier.
Yeah, the subcarriers. And then there is 106 tone RU. There can be two of those. Then you have a 52 tone RU, which there are four. And then lastly, you have the 26 RU, which can be a total of 9. So you can put users. So you can have the single user on a 242 RU, or you can have two users on 106 units. But then there's also what they call the central tones, starting from 106 down to 26 tone RU, which is I think it's 13 and 13 tone RU, but they're in the middle of the channel width. So combined, it's another 26 RU. So I know it sounds like we're just throwing out a bunch of numbers, but head over to the show notes and I show you how that actually gets split out for a 20 megahertz channel width. And then we'll include a table for every single channel width of how many RUs you can have. And that's where the multi-user comes into play, because in that channel width, you can have more than one device that's transmitting or receiving.
Yeah, and I think one day we should do an episode just focusing on the tones and on the subcarriers. So we can keep all these details for a later time. But just to explain a little bit the difference between OFDM and OFDMA with AX. OFDM, we had 64 subcarriers, right? So we had our 20 megahertz wide channels. We would subdivide that in 64 subcarriers. What they did with AX, they multiplied the number of subcarriers by 4, right? So we went from 64 to 256. And so we have more subcarriers. And what they did is they increased the duration of the symbol, right? So they increased the time that you have to send information on each symbol by 4, right? So it's just kind of like if they shifted the space, right? Smaller subchannel, but you have more time to send the data, right? And So now we have 256 subcarriers, and they call it tone, right? That's why Roel was referring to
different
26
tones
tones or whatever. So 26 tones means it's 26 subcarriers, but 26 of the newer subcarriers, right? The AX subcarriers, OFDMA. And that's the minimum size of a RU you can get. So the minimum size of the RU would be 26 subcarrier.
And also to mention, in OFDM, the width of the subcarrier was 312.5 kilohertz. In OFDMA, it's much smaller. It's 78.125 kilohertz. So that's how we're able to fit all these many subcarriers now in a single channel. And when we're talking about all these subcarriers, there's different types of subcarriers. We won't go into detail of every single one, but Francois,
I think we should do an episode on that.
Yeah, and that's just one thing to note, is that there's different subcarriers. You still have your pilot subcarriers, your guard. So that's just something to keep in mind.
Yeah, and I kind of want to talk about why, the reason why they did that. The reason why is they reduce the size of the subcarriers, and that they increase the symbol, the size of the symbol. So maybe we can go over that in one episode and talk about it.
Yeah. All right. So I think the next thing we should
Roel, what I wanted to add to your beautiful image that you created. Good job. You can actually mix and match, right? So
yes,
you could have like the first section of the channel using 26 resource units, and then the second section using 52 resource units, right? So it's very flexible in the way you use those resource units.
Yeah, so I created an image that depicts that, so you can see over time like how those subcarriers are the RUs are divided per client, and so you can see that this is where the efficiency comes in, because you're now not just sending or receiving from one device. It's multiple devices at the same time in a single channel. So that's where the efficiency is coming in, and this is where you and I, Francois, had discussions about how useful is this going to be if you have a handful of AX clients, but then you still have all the legacy clients still operating on the same channel.
So I guess the way you could see it is, the diagram you have, the image you have with the different clients over time. That's what's going to happen within one transmit opportunity. I'm going to call it one AX transmit opportunity, right? Let's say you have a mix of different clients. The AP, if the AP wants to send information, the AP will contend for airtime, just like we do it with DCF. And then once it gets a transmit opportunity, that's when it's going to play with the RU, subdivide it, and send packets to different, send frames to different users at the same time, and do all this cool OFDMA stuff within that transmit opportunity.
Right. Yeah.
Once it's done, then if a AC device contend to the medium, it's just going to use the full 20 megahertz wide channel for the one-to-one communication back to OFDM. And then you could have another AX communication and so on.
Yeah, that's where it uses the single user part of OFDM, but still capable of doing MU-MIMO. And I'm glad you mentioned the transmit opportunity, because if you look at the resource units here, this is a way of scheduling out the communications between the AP and devices using resource units, and it's something that was carried over, I think, from the cellular world, right? I think that's how I recall it being where this technology comes. OFDMA comes from LTE, and it's a way of scheduling out these communications and having this more efficiency. So the AP does have to, like you said, contend for a transmit opportunity, but within that transmit opportunity are these resource units and which clients are going to either receive or send data.
And the AP is in control of that. And like you did a parallel with the cellular technologies. It's, cellular net technologies, the base station or the AP is controlling who's talking, and that's why they're very efficient with roaming. even if you're in a high-speed train, you're going to be able to roam. And so I guess the Wi-Fi and is trying to take the good stuff from that and implement into the Wi-Fi we know. But yeah, that's how it's going to play out within this transmit opportunity.
Yeah, and so I think now we can talk about first start about talking downlink and uplink OFDMA, and we'll talk about downlink first, and then after we talk about uplink, we'll go into a little bit detail of the frame itself and how this is done. But the downlink OFDMA, I think, is by far the easiest part for the AP to figure out, because as it's sending the data, it's already in control, right? It's got the transmit opportunity. It can transmit frames to different clients and split the channel into resource units. And the way that's done is when it does have a transmission for a client, those clients tune their radios to that specific resource unit to receive their transmissions. And I think that's really, really cool and interesting, right? Because the client will receive a frame and it knows which like sub channel to tune into and go, okay, this is the sliver of the 20 megahertz channel I will listen to, and that's how I will receive my transmission.
Yeah, and I think that's how we're going to be able to achieve 1024 QAM. Remember 1024 QAM, like when they said that's going to be supported in AX, everyone's like, you're going to have to be 1 meter away from the
you
AP.
got to be right below the AP or be right next to it.
Exactly. But if you reduce the channel width, you actually increase the SNR. So, if you use a resource unit that's like 2 megahertz wide or 8 megahertz wide, now you have a better SNR, so maybe you have a better chance to achieve the 1024 QAM. I guess we'll see in real life.
Yeah, but can you get that in the 5 gigahertz now, or do we have to wait until 6 gigahertz?
No, we should be able to with OFDMA. I mean, if you get the client gets a resource unit allocated to a smaller resource unit, we should be able to. The client, like you said, the client will only be tuned to listen on those specific tones or specific subcarriers.
Yeah.
So you essentially reduce the channel width, right?
Yes, it'll be interesting to see once Samsung comes out with their phone and the APs that are out now with supporting 11ax to see, okay, how does this really work in the real world? Because like you said earlier, we're reading this in theory and it sounds good, right?
Yeah, and
It's
especially
different.
the fields, right? Like when you get to, we'll talk about the different subfields. But when you get there, you're like, man, I want to know, in Wireshark, I want to see which one
does
would
it
be
look
used,
like, yeah.
implemented, and so on.
Yeah. So, and then now if we talk about the uplink OFDMA, I think this is where I had the biggest challenges in understanding the draft, because uplink, if it's coming from a client, how does it know ahead of time before it transmits which resource unit to use, right? And so it's similar to the downlink OFDMA, except there's going to be this use of a trigger frame from the AP, and that trigger frame that the AP sends is going to coordinate those transmissions and which resource are you for a device to use to send towards the AP. And so the AP solicits this simultaneous response frame from multiple 11ax clients. And then so the thing is if the client doesn't support what's called the TRS control within the frame itself, it's not going to be able to do the multi-user uplink.
Yeah.
And so there's a lot that goes into this, because now we're going to start talking about the actual fields within the frame.
Yeah, the most important thing is it has to be synchronized in time, right? So when for the downlink, so for the traffic coming from the AP going to the clients, the AP is in control. She knows who to talk to. She knows the clients, and so it's easier for her to just synchronize everything in time. But now for the reply, the clients might not know about each other, so they need to be responding on time on different tones, different RUs. so they don't interfere with one another, and they have to do it in a synchronous manner. And we're talking microseconds there, right? So we need the AP to send a trigger frame, like you said, to make sure that everyone is on the same page and everyone is synchronized to send the uplink back to the AP. And I kind of see that as when you go to see a classical music show, you have the conductor.
Yeah.
And he's making sure that all the instruments are playing when they're supposed to play, synchronized in time during the play. And it's kind of like what the AP is doing, right? The AP is sending the trigger frames to let the violin and the piano know that they need to play right now, right?
Yep. I mean, that's a very good analogy, as something in control to indicate, all right, you're going to transmit at this time, and you are this other device, you're going to transmit at this time on this RU, and it's very similar. And that trigger frame itself is what contains the information for those devices after it solicits which clients are going to respond, right? It's going to contain the duration for that response frame, the actual RU allocation, its target RSSI, and the MCS for what's called the 11ax trigger-based PPDU. So this is where we start getting into a lot more detail.
Yeah, a lot more acronyms.
Way more acronyms. All right, so if we go further and talk about, we talked about the RU allocation, and so when the AP indicates which device is going to have this RU allocation, it's actually ordered in the frame from the lowest frequency to the higher frequency, and then it's still hard to direct people where to go. And I guess there's this there's something called the Triggered Response Scheduling, TRS, right? So this is another new acronym. That's what's used for the AP to determine to solicit the 11ax trigger-based PPDU, and in the control field, there is an RU allocation there containing way more data than we've seen from the previous from the standard that's out now.
Yeah,
and
so the RU allocation, it's 8 bits, and I guess you could see it as a mapping. It's like a code, right? So you have 8 bits, and the first one would be 0, 0, 0, 0. So 7 zeros or 8 zeros. The first one is 8 zeros, and if you have 8 zeros, it means that the channels, the 20 megahertz wide channels, is divided in 26 RUs.
Yep.
Right. So in 9 RUs, there are 26 tones wide, and then if you have if the RU allocation is 7 zeros and 1 1, so 0 0 0 0 1, it means you have 826 RUs and 152 RUs, and then the mapping continues like that. So you actually have a table that maps out the code between the RU allocation bits and how the channel will be split in between the different RUs.
Yeah, and that's how the device knows which RU to actually use because of those that bit that's set there.
So it's kind of like, the Morse code. If you receive like that, you know what letter of the alphabet is. So in this case, if the client receives like a 0110011, they would know exactly how the 20 megahertz wide channels will be split, and they will know the size of the RUs.
Yeah, and we'll include the actual table from the draft because you can see how which bit, how that looks like when it splits out the RU allocation. There's a lot of different combinations that can be done. And can you just imagine trying to troubleshoot 11ax, and then for some reason you got to figure out which RU, what was the RU allocation for a device?
That's crazy. And actually, the picture we have is not all the table. If you want all the table, it takes like two or three pages in the draft because you have so many options.
Yeah, that's why we're just referring to the 20 megahertz channel width because it's the smallest table.
Well, anyway, you're gonna have the RU allocation would be per 20 megahertz wide channels, right?
Yeah.
So if we go back to without making it too confusing, but if we go back to the RU allocation, it's going to be placed in the SIG subfield. Field. It's a field at this point, which will be placed right after the preamble, right? And this will have to be sent for every 20 megahertz wide channels. So if you're using a 80 megahertz wide channels, you have to send different RU allocations, specific RU allocations for each 20 megahertz wide channels.
Yeah. So if you have the draft, look at the PHY specification, and you'll see the HE SIG field, and that's where where we got this detail, and how we see, okay, there's a trigger frame. What does it contain? And it lays out the MAC, what that looks like. And so the trigger frame itself, it's going to allocate the resources, where you got the duration, your receive address, transmitter address. You still have all of that, the fundamentals of wireless there, but then now they're adding all these other frames in order to determine things like the downlink and uplink. And I think the uplink is still just the most complicated part, because the trigger frame has to tell each device which RU allocation it has, what MCS to target, the RSSI, and that's what maybe we'll see the 1024 QAM there in the uplink MCS field.
Yeah, so I guess we can talk about that. So we will have the AP will send the RU allocation. So pretty much the AP is splitting the 20 megahertz wide channels into different RUs. But then how do we know which RUs is assigned to which client station, right? And that's when you have the user field. Let me get the exact nomination. The user field. And so right after the RU allocation, you're gonna have multiple user fields, right? And then you're gonna have, if the AP talks to 10, let's make it simpler than that. 4. Let's say the AP talks to 4 clients at the same time. You'll have 4 user fields, and then in each user field you'll have the station ID, right? So you'll know exactly which clients the AP will be talking to. And then the AP will also specify, the number of special streams, the MCS, so which modulation it will be used to send the data. So the clients will pretty much know that the client will be expecting to receive information from this frame for him. It will know exactly on which resource unit, and it will know exactly how to decode it.
Yep, and that's where the AP will be listening on those tones, on those sub frequencies, I guess, in the channel. And that's how, on the uplink side, I think is still just the most complex thing to me in understanding how all of that works in such a small time frame.
Yeah, it's pretty, and that's why they start to put like processors in APs and stuff like that, because it's, from the math perspective, it's very complex. And then when you start to mix that with multi-user MIMO, the complexity goes high, because now you can have, and that's when it reminded me of the Inception movies. You have dreams within dreams, so
yes.
You could have user field within user fields.
Yeah. And, so and there will be specified the spatial streams.
Yeah, exactly. Because now in one resource unit, you could have one resource unit assigned to multiple users. And the first time I read this, I was like, "What?" But yeah, if you think about it, if you have
how many layers deep are we going into the stream?
Exactly. If you use OFDMA and multi-user MIMO, now you could have the resource unit assigned by OFDMA, and then within that resource units you could have 8 streams. So you could divide those 8 streams between different users, and then now you have multi-user MIMO and OFDMA. So you need to be able to identify those different users using the same resource unit. I know it's confusing, but
it's very confusing. And this is why I was jumping between multiple sections of the draft, but we only wanted to bring up the things we thought were very important in understanding how 11ax resource units works. And I think we touched upon most of the major parts. just remember the downlink part is the easiest portion for the AP to do because it's in control. It's got the transmit opportunity. It then knows how to allocate those RUs. It's the uplink side where it must send a trigger frame, and then the trigger frame contains which resource units a device will use, and a device will respond to that trigger frame with a trigger-based PBDU, which has all those details that it was allocated to.
And just to add to that, I think we're not gonna. I believe I read it in the CWNA book, but I don't think we're gonna see OFDMA and multi-user MIMO implemented at the same time for now. Maybe in wave 2.
Yeah, that's probably one of the features that could be split out into waves.
It adds a lot of complexity, right? Yeah, the AP would become like a computer.
Yeah, because
powerful computer.
Yeah, I don't know if you saw all the different math formulas within the draft, but there's quite a lot, and then it makes me think I should have paid more attention in school with math,
the matrix, and
But yeah, if you want to understand exactly how it works, and you love math, the draft is full of all these fun formulas that I'm sure will be useful for somebody to put together and come up with this information. But I mean,
and then you always have the the difference between what's in the draft and what is actually implemented by the manufacturers. So I guess we'll see that. We'll start to see that, and I guess. But if you know all this stuff, if you know the draft, now you're able to read the the Cisco documentation data sheet or the AeroHive data sheet and know exactly which feature is implemented and how it's going to benefit your environment.
Yeah, so hopefully you guys now understand the big impact that resource units have on 11ax and how that actually improves wireless transmissions and I guess what you can call the high efficiency of Wi-Fi and why it is more efficient, right? And how we allocate more, I guess have more transmissions over a single frequency. And I think that's the biggest part of 11ax and why we are going to be implementing it soon with devices and APs. But like you said, Francois, it could be different implementing it based on what we see here. Just theory-wise, this looks pretty good. It looks advanced and it may work, but we actually need to see this implemented in a dense environment because we do have vendors that are touting that this will fix things like 2.4, right? Like 2.4 will come back because of the high efficiency. But is that the case when you have like how dense does an environment have to be before we break the high efficiency?
Yeah, and then I think for the transition period, I think I heard it from Devin. They're gonna try to come up with access points that have multiple radios, and then they would have like one radio dedicated for AX communications, and then another radio for all the rest, and then they would have a steering mechanism to steer the AX clients to the AX radio to try to take advantage of all of these good new features.
Which means more complexity on the AP itself.
Yeah, the AP will become like massive. That's what they're starting to get worried about PoE budgets, and am I going to have to change my switches? And then can you imagine the size of the cable that connects the switch to the power?
Is this why we're going to have 10 gig to the AP?
I'm not sure, but I'm more thinking about the at home you have your dryer connected to the power and it has this big cable.
Yeah,
we're going to see that in switches.
Well, hopefully not. Well, I think that's all we have for 11ax OFDMA resource units. Hopefully you guys were able to follow along. We will include links and images and screenshots of the tables within the show notes. So if you head over to cleartosend.net/160, that's where we will have all the information. We'll also include links from the news that we mentioned earlier, but we will continue on this 11ax series because there's still much more to talk about, which still adds more complexity, things like BSS coloring. which we haven't even really dove into yet. And there's also the target wait time, which could add even more complexity, because if an AP is going to send a trigger frame, what if the client's not awake to receive that? I don't know. So
a lot of stuff to talk about, but it's very exciting.
Yeah, I think as we go along, maybe near the end of the series, we can finally have a really good idea of how 11ax works, and maybe we'll revise what we've said in these earlier episodes. After
maybe we'll have packet
picture.
captures.
Yeah, by then we'll have the clients and the APs. But and that's all we have today in this episode. Francois, do you have anything else to add?
No, I just wanted to say, let us know if it's useful, if it makes sense to you guys, if you understood the draft differently. We might make mistake in how we interpret stuff. So, we'd love to hear from you guys as well, if you want to add to what we've explained today. And that's it.
Yep. Anything you're working on this week, Francois?
Not much. I'm working for a small clients in Toronto. So yeah, so it's like a non-profit association. So I'm working with them to set up their new Wi-Fi.
Awesome.
Yeah, that's good. What about you?
I'm working on some new designs for different buildings, multiple floors, trying to redesign areas that still have old Cisco APs, like 3500 APs, and putting in new ones. More and more people are, I guess, trying to do roaming or Zoom conferencing over wireless. So trying to accommodate those needs, and also make sure lecture halls have better Wi-Fi for the students that with the interactive teaching. I don't know if you've heard about this, but there's professors that do interactive teaching, where to try to engage students, they have them do like a sequence of steps, but using their laptops or computers over wireless. So I've had to deal with improving wireless in a couple lecture halls where there was just too many students using the wireless in that area, and that was only designed for coverage. So still working on that.
So you need AX.
I need AX to get here. I need those 9100 Catalyst APs. But first I need the clients.
Well, just tell the students to buy Samsung phones.
Yeah, that's what I'm going to say.
Problem solved.
just get Wi-Fi 6 clients, guys. All right, well, that's it for our episode. If you guys have any questions, head over to the show notes, cleartosend.net/160, and hit us up on Twitter @cleartosend if you do have any other discussion you want to bring on there. But other than that, we'll see you guys on the next episode.
See you guys.
Bye.